right, welcome back to Physics with Miss McQueary, everyone. Today we're going to actually go through an example problem when it comes to the kinematic equations and how to just walk through one of these, okay? So the first thing we're going to do is we're actually going to read the problem all the way through, right? After that, there's a series of steps we can take to make our lives easier. First one is going to be drawing a picture and identifying our given information. As we read this, a couple of things are going to start to stand out. Number one, anything that has a number in it is really going to smack us over the head that it's important and we need to write it down. So, for example, the fact that Fred is moving at 30 meters per second is something that we should probably write down. So we're going to go ahead and we're going to write down that number, and then we're going to also write the corresponding, is it initial velocity, final velocity, acceleration time? Whatever that variable is, we need to record that as well. So we would write 30 meters per second equals initial velocity, or VI, all right? Now we're also reading through this, and -8 jumps out at us, -8 meters per second squared. So we're going to go ahead and we're going to record that as well. So -8 meters per second squared is equal to, it says acceleration, so that equals A. Now with most of these example problems, we need to have 3 different variables that are given to us. And not all of them are going to be quite as obvious as 30 or -8 or spelled out exactly for us. We need to read between the lines a little bit. As we read through this, it says that Fred is applying the brakes and he skids to a stop. Now, hopefully, if you're going at a stoplight, you eventually come to a stop, right? You want your final velocity to be 0, to be at rest. So the third thing that we need to write down for our givens is that V sub F is equal to 0. All right. And when you do all that, it should start to look something like this. Okay, we have our picture drawn. We have our acceleration is identified. We have our initial velocity and our final velocity that we've been able to pull out of the equation or out of the example problem to write down. And we've been really careful to keep our signs positive and negative, right? Your initial velocity should be positive because you're going to the right, and acceleration is working against you because you're slowing down, and that's why it is negative, all right? If we had initial velocity going to the left, we would have to make it a -30 meters per second and then make it a positive acceleration because it's working against it, all right? So just be very careful. There is a reason why you have a positive sign or a negative sign in front of these numbers. All right, the next step is going to be determining what exactly you're trying to solve for. So for this case, it says that we are trying to determine the displacement. All right, so that displacement is going to be something we write down. And if you have a highlighter on you, you can highlight it, or a lot of my students like to underline the givens and circle the thing you're trying to solve for. All right, so now we have this nice, lovely picture in front of us. There's a couple things I want to share with you. Number one, when you're trying to solve, trying to figure out what your unknown variable is, the language can be something that kind of gives away your answer. For example, I might say determine the something, find the something, calculate the something. Those are all signs that what's coming next is what you're trying to solve for. The other thing that a lot of my students have been very keen on is when you're labeling what these things correspond to, like, so 30 meters per second. How did we know that was initial velocity? Well, sometimes the units can be very helpful. If you have something that's in meters per second squared, it's always going to be acceleration. Meters per second is always going to be some sort of velocity. Meters will correspond to distance or displacement, and then seconds are obviously going to be time. So sometimes you can use those units to help out. Okay, at this point right here, once we have all of our given information and we've listed our unknown, we're going to have to determine which of these equations we're supposed to use. Okay, so we want to find one of these equations that has all 4 of those variables in it. It has to have initial velocity, final velocity, acceleration, and displacement in this case. There's only going to be one of them that has all 4 of those. And in this case, it's our top right equation. And of course, this will change. Sometimes you might not be given displacement, you're given time, and you must use different equations, or maybe instead of final velocity, they give you another variable, right? So, it'll be different each time. And eventually, the more times you do this, the more comfortable you're going to get with selecting the relevant equation. All right. From there it becomes basically an algebra problem. Okay. We've worked really hard to identify our givens. That way we can just plug them straight into our equation, or we can substitute them in. All right. Once you do that, it becomes the algebra problem to solve for that missing variable, aka your unknown. And then we double check to make sure that our answer is relevant. So if you're going from 30 meters per second to 0, and you're only slowing down at -8 meters per second squared, it might take you 56 meters, all right? That is, that's over half of a football field to slow down. So this is one of the reasons why they tell you don't text and drive, for example. Even a few seconds where you're not looking at the wheel can really make a big difference when it comes to the distance you have and also the time you have to react to these things. So this has been an example of how to solve the kinematic equations step by step. I hope that this helps. And until next time, we'll see you.